Hello and welcome everyone. This is Mohammad Izamam from SAIMEDHA ECET Coaching Center Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing a golden opportunity to all the ECET 2024 and as well as ECET 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, SAIMEDHA Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. Ranks గురించి చెప్పాలంటే SAIMEDHA Koti, Hyderabad లో every single time, every single year we have proven that maximum ranks in all the branches ECE, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous ECET examination questions will be explained by expert faculties. My dear students, గుర్తుపెట్టుకోండి, ఓన్లీ ప్రీవియస్ ఇయర్ కాంపిటేటివ్ ఎగ్జామినేషన్ క్వశ్చన్స్ కొరకే సపరేట్ కోర్స్ ఉంటుంది, పే చేయాల్సి ఉంటుంది బయట మార్కెట్లో. కానీ SAIMEDHA Koti, Hyderabad లో ఫ్రీ ఆఫ్ కాస్ట్ we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous ECET examination questions with which you can understand the level of teaching, the expertise which is there in the SAIMEDHA Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the ECET 2024 and ECET 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video.
Let us see the next question over here. The degradation of the mechanical properties leading to a failure of a component due to cyclic loading is called. Okay, what is the options we are having over here? Breaking, yielding, creeping and fatigue. So if you are remembering only this word, now what we are having over here, cyclic loading, by using this part only we can give the direct answer over here. Whenever we are having the cyclic loading, then we can go for fatigue. Okay, we are calling this property as what? Fatigue. Or else we can remember the one definition also, fatigue strength. What is our definition of fatigue strength? Means the maximum stress at which the material, the maximum stress at which the material will operate indefinitely without failure. Okay, whatever this maximum stress, now we can write this part as varying loads will be there. Varying loads means if you are remembering this definition, sometimes this definition will be given, or else if you are having this part as cyclic loading, whenever we are having this cyclic loading, directly we can go with the option as a fatigue over here. Okay, now let us go for the next question. A body having similar properties throughout its volume is said to be. Okay, now what we are having over here, a body is having the similar properties throughout its volume. So actually what we are taking this part means, suppose let us take this one. Now we have taken a body example we are taking over here. Now in this part, whenever we are already we have taken this, whenever we are having we are taking in this direction, let us take it as E1. This part we have taken it as E2 and this part we are taking it as E3. Similarly, one more point we have taken in this, we are taking it as E1, this is E2 and this is what? E3. Okay, so we are having the same elastic properties over here. We are having what? Same elastic properties in the direction. So it is depending on the direction but independent of the what? Point. Okay, so it is similar we are having over here, having similar properties throughout its volume, so related to what? Homogeneous part over here. Okay, if this part is given, this sentence is given, we are having the same elastic properties depending on the direction independent of the point, or else we are having it as similar properties throughout its volume, then also we are calling it as what? Homogeneous. Isotropic, what we have taken, isotropic was different. We are having same elastic properties in all directions. Whenever we are having what? Same elastic properties in all the directions, then we are calling it as what? Isotropic. Okay, so this part we have taken. Now next, the dimensions of Young's modulus of elasticity are. Now let us see this one, what we are having the dimensions. So Young's modulus of elasticity means modulus of elasticity, what is the units we are having? So units we are having it as Newton per meter square. Okay, so we have written the new units. After writing the units, with the help of the units, let us try to find out the dimensions what we are having over here. Newton per meter square we have taken, but 1 Newton is equals to how much? 1 Newton, it is equals to 1 kg meter per second square. What we are having? 1 kg meter per second square. Now let us substitute over here. In the place of Newton, we are writing 1 kg meter per second square. Then again in the denominator only what we are having? Meter square we are having. So let us write this part as meter square. Okay, so this 1 meter gets cancelled. Now what we are having? Kg we are having in the numerator, and in the denominator we are having meter and second square. Okay, now let us try to write in this mass, length and time over here. Okay, now what we are taking? Kg means what we are having? Mass. So we have taken mass over here. What is the power we are having for this mass? Means 1. So we have taken 1 over here. Now next, m we are having. M means what we are having over here? M means a meter. What is the meaning of m over here? Meter. So if you are having meter, we have to take length. So we have taken length over here. Okay. But what is the power we are having over here? M power 1 is there. But if you want to write in the numerator, it will become what? L power minus 1. L power minus 1. Similarly, now S means what we are having? Second. Second square we are having. Second, it is related to what? Time. So we have taken t over here. Now what is this number we are having? 2. Means if you want to write in numerator, means again it will become what? Minus 2. So these are the dimensions of what? Young's modulus or modulus of elasticity. Okay. So if you don't know that directly what we are having the formula dimensions over here, then with the help of the formula also we can write this part. Okay, so m L power minus 1 t power minus 2 will become the dimensions of the Young's modulus. So which option is correct over here? M L power minus 1 t power minus 2. So option 3 is correct. Now next question, the shear stress on principal plane is, already we have discussed this part. Now listen here carefully. Suppose we have taken a body over here. Okay, this body we have taken. Now in this we are having this normal stresses, sigma x we have taken, this is also sigma x we have taken. Now this is sigma y we are taking, this is also sigma y we are taking over here. What is the meaning of normal? Normal means what? Which is perpendicular to the cross section. Yes or no? Perpendicular to the cross section means we have taken this part. Now if you are taking shear also, means shear means what? Parallel to the cross section. Parallel means what we are taking over here. Suppose we have taken like this. Okay, this part we have taken. So if it is moving in right direction over here, another part we have to take it as what? Left direction. Okay, right and left we have taken. Now if you are seeing this one, if you are seeing this part right and left, so it is trying to rotate this body in clockwise direction. If it is trying to rotate the body in clockwise direction, we have to provide the complementary shears which is opposite to that part, so the body will be in stable condition. Okay, so if it is clockwise means now we are providing anti-clockwise over here. So this upward we have taken, and over here what we have to take a downward. Okay, like this we have taken. So whenever in addition to normal stresses, if you are having the shear also, then we are calling it as what? A complex stresses. What we are having over here, we have taken this part as a complex stresses we are calling over here. Now in this complex stresses, whenever shear stress it is becoming 0, whenever what? In this complex stresses only, if shear stress it is becoming 0, then we have to call it as a principal stresses. Okay, now so over here also what we are having? Shear stress on principal plane, and that plane what we are calling? Plane we are calling it as a principal plane. Okay, shear stress is 0 means we are calling it principal stress. That plane we are calling it as what? Principal plane. So shear stress on principal plane will be equals to what? 0. 0 means what? Option 3 is correct. Now next, the maximum shear stress is equal to, already we have done this question also, maximum shear stress. So tau max it is equals to, what we are getting over here? Under root sigma 1 minus sigma 2 divided by 2 whole square plus tau square or xy, like this we have taken over here. But in this it is asking about maximum shear stress, tau max it is asking, but we are not having any tau value over here. If you are not having any tau value, so this part will become 0 and the square root gets cancelled. So what we are getting over here? Tau max it is equals to sigma 1 minus sigma 2 divided by 2. Okay, this part we have taken. Or else, so what is the meaning of that sigma 1 sigma 2 actually? So we can also write it as sigma maximum. What it is? One means maximum minus minimum, maximum minus minimum divided by 2. Okay, sometimes it will be given in maximum or minimum words, or else it will be given like some normal principal stresses only. Okay, so let us see this one. Sum of the principal stresses. Sum means what we are having over here, sigma 1 plus sigma 2. Difference of the means sigma 1 minus sigma 2. Okay, now third, what we are having, half of the sum of the principal stresses. Half of the sum of the principal stresses means sigma 1 plus sigma 2. Okay, now similarly half of the difference means what we are writing over here, half of the difference means sigma 1 minus sigma 2, half means divided by 2. So we are getting this answer over here, sigma 1 minus sigma 2 by 2. So let us go with fourth option. Okay, so directly we can remember over here, whenever we are having maximum shear stress, main formula is this part only. But if you are substituting some value, if you are considering only principal stresses over here, tau value is equal to 0 we are taking, then we are getting the answer as half of difference of the principal stresses. Okay, so directly we can remember this part. Now let us go with the next question. The phenomenon of slow and progressive deformation with the time at high temperature is called. Okay, now listen carefully. Already we have discussed this part also. What we are having the definition over here, slow and progressive deformation, with the time at a constant stress. Slow and progressive deformation with the time at constant stress, we are calling it as what? Is called creep. What we are calling is called creep. Okay, already this question has been repeated over here. So the phenomenon of slow and progressive deformation means directly we can go with what? Third option. Okay, creep or creeping. Now next, the maximum shear stress occurs on principal planes, 45 degree with principal planes, 90 degrees with the principal planes, independent of the principal planes. Okay, now let us see this part. The maximum shear stress, it is occurring on. Over here what we have discussed, maximum shear stress is equal to means we have taken this part, but over here what we are having, maximum shear stress occurs on. So as you have already seen in the video lectures that what we have taken over here, suppose this part we are taking it as principal plane 1. What we are taking, suppose this is principal plane 1, then we will be having another principal plane also. Let us take this part as principal plane 2. Okay, this is principal plane 2 we have taken. And what is the angle between this principal plane 1 and 2 means it is equals to 90 degrees. Now in this part what we are having, for this plane, whatever the normal we are taking over here, this part it is becoming what? A maximum. Okay, normal stress what we have taken, it is becoming what? A maximum. Similarly, whatever the shear part we have taken over here, okay, shear, we are not having any shear. If you are not having any shear means then tau it is equals to 0. Okay, this part we have taken. Similarly, on the principal plane 2, whatever the normal means what? Perpendicular should be there, no? So that's why we have taken perpendicular. This is also what? A perpendicular. So if you are taking perpendicular over here, this part will become minimum. And this what we are taking over here, in this also tau value it is equals to 0. Okay, this part we have taken. Now next, principal plane 1, principal plane 2. But if you are taking these principal planes, we are getting tau value is equal to 0. What we have to find? We have to find maximum shear stress. So we will be having shear planes also. So this we are taking it as, this is shear plane 1. Similarly, this part will be shear plane 2. Okay. So shear plane 1, shear plane 2 we have taken over here. Now in this, whatever the shear will be there, now whatever the shear we are having over here, it will be tau max. Maximum shear will be there in the shear plane. Okay, and similarly over here also we will be having what? A tau max. So in this shear planes we will be having what? A maximum shear stress. What about normal? What we are having over here means, let us take this part as a sigma n. Okay, sigma n. Let us normal. We are taking this part as what? A sigma n, perpendicular to the cross section. Okay. Now, what is the angle between principal plane 1, principal plane 2 means we are having 90 degrees. Similarly, what is the angle between the shear plane 1 and shear plane 2? It is also what? 90 degrees. But what is the angle between principal plane and shear plane? Means it is equals to what? 45 degrees. This is what? 45 degrees. Understood? So I will write over here. So the angle, this is most important points we are having. So angle between two principal planes is equals to 90 degrees. Similarly, angle between two shear planes, it is equals to 90 degrees. Then next, angle between one principal plane and one shear plane, it is equals to 45 degrees. Okay, we have taken this part. So whenever we are having the angles over here, angle between the two principal planes we have taken 90, two shear planes we have taken 90, one principal and one shear we have taken it as what? 45 degrees. Okay, so the maximum shear stress occurs on principal planes, means that is wrong answer. 45 degrees with the principal planes. Yes, if you are taking this shear plane over here, what we are having, it is at 45 degrees. Okay, or else if you are taking this part also, it is also at 45 degrees. So at 45 degrees to the principal plane. So second option is correct over here. Okay, second option is correct. Now next, a bar of length L meters extends by a mm under a tensile force of P. The strain produced in the bar is. Okay, now listen here carefully. So strain, we have to find out the strain over here. What is the strain formula? Change in dimension by original dimension. Okay, so change in dimension by original dimension means, as it is given length over here, let us write delta L by L. So we are writing L only, this part is L over here. Okay, L meters, we are having L meters, but this delta L value is given in mm. A mm is given. A means some value. A means what is some value we are having. Mm we are having. But if you want to convert from mm to meter, then what we have to do? We have to divide by 1000. Yes or no? We have to divide by 1000. So A divided by 1000 we have taken over here. A divided by 1000 means what we can write now? 0.001 A. Okay, so this is delta L value. Delta L value is equals to what we are having? 0.001 A. Okay, so let us write over here. So 0.001 A divided by L. So this is a water strain. So this is delta L value. This is only delta L value we are having. It is given as A mm. This mm we have to convert into water meters. So A we have written as it is, and mm to meter means we have to divide by 1000. So we are getting 0.001 A, and we have written delta L by L is equals to water strain. So which option will be correct now? A by L, 0.1, A by L, 0.01, 0.001 A by L means 0.001 A by L means fourth option is correct. Now let us go with the next question. The units of modulus of elasticity are same. Okay, the units of modulus of elasticity are same as those of stress, strain and pressure. Means the stress and pressure units it can be same, but strain we are not having any units over here. Okay, now similarly stress and modulus of rigidity it can be same, but force units what we are having means newtons. Force will be what? Newtons. Stress is what? Newton per meter square, but force is newtons. So this is also wrong. Again this also force means again we are not having same units over here. But in this stress, pressure and modulus of rigidity, all these three whatever we are taking over here, all these units will be same. Newton per meter square will be getting the same units over here. So let us go with the fourth option. Now next, the Poisson's ratio of most of the materials is. So we have written number of examples over there. What we have taken? Concrete example we have taken. Cast iron numbers I have given, steel numbers I have given. Okay, then copper we have taken, brass we have taken, aluminium we have taken. Okay, after aluminium we have taken rubber also. Then cork we have taken. For cork what we have taken? 0. For rubber what we have taken? 0.5. and all this we have taken in the middle of this range only. Okay, so the Poisson's ratio of most of the materials will be lying between what, 0 and 0.5. Okay, 0 and 0.5 means option 3 is correct. Now next, the composite bar of copper and steel is heated. Now we are having composite bar over here. Okay, listen to this part carefully. Composite bar. A composite bar of copper and steel is heated. The ratio of tensile stress in steel and the compressive stress in copper would be considering, we are having E values over here. Young's modulus for copper is given, Young's modulus for steel is given. We have to find out the ratio. Now for composite bar we are having some two conditions. First let us discuss that part very carefully. Composite bar. For composite bar we are having some two conditions over here. First condition we are having it as P is equals to P1 plus P2. What we are having, total load. Total load is equals to algebraic sum of the loads over here. Algebraic sum of the what? Individual loads. Okay. So this is first condition we are having for the composite bar. Means if you have taken two materials means P1 plus P2 we have taken. If you are taking three materials means P1 plus P2 plus P3, like that. Algebraic sum of the individual loads, it is equals to total load we have taken. Okay. Now next condition. Next condition what we are having means whatever the strain will be then a strain. Okay. Strain of both the materials will be same. Okay. So if you are discussing this part, strain, whatever the strain we are getting in steel, which is equals to strain we are getting in water, copper. Okay. So these are the two conditions we are having in composite bar. Now let us discuss this, what we are having over here. Okay. Now what is the formula for strain we are having? First we are having this part, E is equals to modulus of elasticity is equals to sigma by epsilon. If you are sending this part means epsilon, it is equals to sigma by E. Okay. Now we are using this formula. In the place of epsilon, what we can write, sigma by E. So sigma S divided by ES, which is equals to sigma C divided by EC. Okay, this part we have taken. So what we have to find actually, we have to find the ratio of stress in steel, this part, and stress in copper. So we are taking this part as stress in steel divided by stress in copper, which is equals to, let us send this ES part over here. So ES divided by EC, okay, which is equals to, now let us substitute the values what we are having. What is ES value we are having? 2 into 10 power 6, 2 into 10 power 6 divided by EC value what we are having, 1 into 10 power 6. This 10 power 6 gets cancelled and it is equals to 2. Okay. So what is the answer we are getting over here? The ratio of tensile stress in steel and the compressive stress in copper, it is equals to 2. Okay, we are getting the answer as 2. So let us go with the fourth option. Fourth option, it is equals to what? 2.
So my dear students, for ECET 2024 and ECET 2025, SAIMEDHA KOTI Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi SAIMEDHA KOTI Hyderabad in this very week, guys. In this very week only, we are providing the maximum concessions. ఆ కన్సెషన్స్ ఏవైతే ఉన్నాయో కన్సెషన్స్ ఏ విధంగా ఉంటుంది, బ్యాచెస్ ఏ విధంగా ఉంటాయి, విత్ మెటీరియల్స్, వితౌట్ మెటీరియల్, ఆన్లైన్ కోచింగ్, టోటల్ మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద SAIMEDHA KOTI Hyderabad as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous ECET examination questions. I wish you all the best. This is Mohammad Inzamam signing off.